We have an ideal gas law problem. Reminder, an ideal gas is a gas that obeys the ideal gas law. Now we know atoms and molecules can't read. What that really means is that the measured properties of this gas are consistent with the ideal gas law, which is PV equals nRT. When you use the ideal gas law, you want to be careful to make sure you use the appropriate units. Let's pay attention to the measured values in this question. We have our given number of moles, we know the volume of our gas in liters, and we know our temperature. And we know we're given a nice, easy introductory problem. We see that N is already expressed in moles, the volume is expressed in liters, the temperature in Kelvin. All right, let's start with the ideal gas law. And in this problem, we're asked to calculate the pressure. So we want to solve the ideal gas law for the variable pressure. So in our algebra, we divide both sides by volume. We want pressure by itself on one side of the equation. Now all we do is substitute our numerical values and churn it out. Here's our result. Remember, units are your friends. They can help you know if you set up the problem correctly. We see here moles cancel, liters cancel, and K cancels. The only unit that survives is atmospheres, which is a unit of pressure. We're asked to solve for pressure, so this is good. We get our numerical value, look at sig figs. We see that we can justify 3 sig figs, so we're dropping the 8 and everything else. We have to add 1 to the preceding sig fig, and we're done.